Hey guys, I hope everything's going well. You guys did a great job on the last two parts to this unit. Today's lesson is a continuation of factoring with special circumstances, special factors, and it's 21.3 in your book. And today's lesson will be the difference of two squares. So tomorrow you'll have an IXL lesson that corresponds to 21.3. But for today, I'm going to go through the lesson, give you a little video, and ask you to do 5 or 6 problems on Google Forms like we've been doing. And then we'll promote you guys onto the IXL examples on the next day on Thursday, okay? All right, if you have any questions, make sure you get in touch with me. And definitely, I'd be glad to set up a Zoom call with you and go through these things. So when you view this first example, you can see that both the 64 and the 9, the lead coefficient, are both on your perfect square list. 8 times 8, 3 times 3. Since the variable has an even exponent, we know that that also is a perfect square. X times x, x squared times x squared. So as I just mentioned, if we were to multiply 8x times 8x, we would get 64x squared. And if we were to multiply 3x squared and 3x squared, we would get 9x to the fourth. Now, what's different about this one than the ones we did yesterday is there's no middle term. Okay, so this is the difference. Remember, subtraction. The answer to a subtraction problem is called the difference of two squares. Okay, so how do we eliminate that middle term in a trinomial? Well, it would be where you would have two equal terms that were subtracted from each other, is the way I'm trying to say it. So if we went like this, and we made that negative and that plus, watch what happens to the middle term. The outside would be 8x times negative 3x squared, or 24x to the third. And the inside, 3 times 8 would be 24. X squared times x would be x to the third. This one would be positive, the other one would be negative, and there would be no middle term. So there you go. So this is the difference of two squares. So the point being is, if you have a binomial, and this is a perfect square, and that's a perfect square, and you have a minus in between, it's a special example for factoring where, pretty simply, we just go like this. Okay, well, what two factors, again, perfect square, would be equal to 9x to the fourth? So we would put 3x squared and 3x squared. And what two factors of 16x squared, would be the same, and when multiplied together would give you 16x squared? Well, 4x and 4x, right? Okay, now we just go like this, minus, plus, or plus minus, either way. And that's it. Your factoring is done. That is your final answer.
And you can always factor it in the following really simple way. It's just the product of a plus b with a minus b. So a plus b times a minus b, always when you FOIL that out, you're going to get a squared plus b squared. Why? A times a squared. The outer terms produce a negative ab, and the inner terms produce a positive ab. So they actually cancel to give 0, and I'm left with b times negative b, which is negative b squared. There you have it. So now, armed with that, you can do all sorts of wacky, zany, crazy things. And what I want to know is, for each of these, do we in fact have a difference of two perfect squares? Let's look at the first one. Is that a difference of two perfect squares? The answer is absolutely. X squared is a perfect square. 100 is a perfect square. So I can instantly factor this as x plus 10 times x minus 10. I love it. Let's try another one. See if I can make it a little bit harder for you. 4w squared minus 9z to the fourth. Difference of two perfect squares?
Yes.
Yeah, actually yes. Because in fact, this is actually 2w all squared, and this is actually 3z squared all squared. You see? So here we can actually factor this as 2w plus 9z squared times 2w minus 9z.
He's wrong.
And
Threes,
if you FOIL that out,
not nines.
typo. Why'd you
Yep, he made a mistake, guys. Sorry.
It's supposed to be 3. There we go.
3 goes in there.
Because if you would check that, you would have seen that I was wrong. In fact, it's supposed to be 3 because that is 3z squared all squared. If you take 3z squared and you
3
square
times
it,
3 is
you
9, not
actually
9
produce
times 9, you knucklehead.
9z to the 4th, which is what we want. So there we have it. Now it's correct. That's good. It's always good to find your own mistakes. And you can actually FOIL this out and see that we're going to get 4w squared minus 9z to the 4th. The z to the squared, the z squared, and the two perfect squares. Well, w to the 6th is a perfect square. It's w cubed squared. So that's good. And that's a difference, so that's good. Z to the 4th is a perfect square. It's z squared squared. But what about 8?
Nope.
8 is not a perfect square. There's no whole number that when I square it, I actually produce 8. So in fact, this is not a difference of two perfect squares, and so I can't just easily use this difference of squares formula. In fact, I'll just leave it like that.
Now, if you refer to your perfect square sheet that I sent out yesterday, you would know that 13 times 13 is 169. So that is a perfect square. 13 squared is 169. So we go like this, x and x. And then we put, okay, the two factors for 169 that are the same, 13 times 13, and go plus, minus, and we are done. Okay, so that's about it from here. This is a fairly easy lesson, and I think that you'll be fine with it. And again, it's special type of factorization when we have a binomial with two perfect squares with a minus in between it. So this can't always be used. It's just in that special set of circumstances. So anyway, like I said, you're going to have, I'll make up 6 problems on Google Forms for you to do. And then tomorrow you'll have an IXL assignment. Have a great night. If you have a question on this, please let me know. You guys are doing a great job. Keep up the good work. Stay safe.